Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. Okay, moving on to part 5 now. Part 5, selection and erection of equipment, is broken down into 6 chapters. Chapters 51 through 56. Now, chapter 51, which is what we're going to cover here, is common rules, and this is information that is relevant to all of the other chapters. So the other chapters: selection and erection of wiring systems, protection, isolation, switching, control, monitoring, earthing arrangements, other equipment, and safety services. This first chapter is relevant to all of that. Common rules. Chapter 51. Okay, so we'll go to chapter 51. Common rules. What have we got? We have. This is what stuff's going to really start feeling as if it's repeating itself now from way back in the part 1 video where we did scope, objects, and fundamental principles. Some of the things that we mentioned also in the part 3 videos, assessment general characteristics. Yeah, a lot of stuff's going to start feeding back through now. So 510.1. This chapter deals with the selection of equipment and its erection. It provides common rules for the compliance with measures of protection for safety, which is all of part 4. Requires for proper functioning for the intended use, which we heard that in part 1. The installation and requirements appropriate to the external influences. 510.3. Every item of equipment shall be selected and erected so as to allow the compliance with the regulations stated in this chapter and the relevant regulations in other parts of BS 7671. The phone's going mental right now. So, last bit there though, in other parts of BS 7771, and it shall take account of manufacturer's instructions. 511. Compliance with standards. Every item of equipment shall comply with the relevant requirements of the applicable British or harmonised standard appropriate to the intended use of the equipment. The edition of the standard shall be the current edition, with those amendments pertaining at a date to be agreed by the parties to the contract concerned. Alternatively, if the equipment complying with a foreign national standard based on an IEC standard is to be used, the designer of the other person responsible for specifying the installation shall verify that any differences between that standard and the corresponding British or harmonised standard will not result in any lesser degree of safety than that was afforded by compliance with the British standard. Such use shall be recorded on the appropriate electrical certification specified in Part 6. Now, we covered this right at the beginning when we talked about departures. We talked about deviating from the regulations and the need to create a departure, and it has to be recorded on the certificates. So it's all repeating itself a little bit now. Okay. Where equipment is to be used is not covered by this standard or is used outside the scope of the standard, again, the designer or other person responsible for specifying the installation will confirm the equipment provides at least the same degree of safety, so no less a degree of safety that would normally be achieved by compliance with the WINE regulations. 512. Operational conditions and external influences. So, all equipment, we must understand the operational conditions of the equipment, which we're going to list here, and the external influences that are relevant to the installation that the equipment must be selected against. So the operational conditions, we must know the voltage. So it should be suitable for the nominal voltage UO. So if it's a 230 nominal voltage, the equipment should be selected for that nominal voltage unless it's part of within the system, such as a self or PELV area. The current, again, similarly, we must take account of the design current, considering any capacitive or inductive effects. Good example of that would be like a motor with power factor correction. Okay, and the current likely to flow in abnormal conditions for such periods of time as are determined by the characteristics of the protected devices concerned. So we will need to consider the current likely to flow in abnormal conditions for periods of time determined by the characteristics of the protected device. In other words, we must consider the high levels of current that could flow for very short periods of time, which is all dictated by what the protected devices are. The protected devices are long duration devices like 3036 fuses, then obviously we need to consider that. If they're rapid devices, then there's less consideration needed. Frequency, we need to know the frequency. Yeah, the characteristics, the rated frequency, and then we select equipment accordingly. Power, every item of equipment shall be selected on the basis of its power characteristics suitable for the duty demanded on the equipment. You need to make sure the equipment is selected and it is of a suitable power demand for the nature of the demand that we placed upon it. If it's going to be asked to do too much, its life will be diminished and it will start to become damaged and maybe even overheat and catch fire. So you must make sure that you recognise or you understand the demand placed upon equipment at the selection stage. Compatibility. Every item of equipment shall be selected and erected so that it will neither cause harmful effects to other equipment nor impair the supply during normal service, including switching operations. Any switchgear, protected devices, accessories, or other types of equipment shall not be connected to the conductors intended to operate at a temperature exceeding 70 degrees at the equipment in normal service unless the equipment itself or the manufacturer has confirmed the equipment is suitable for such a condition. So if you're entering a cable, you're going to wire a system and the conductor was to exceed 70 degrees, you would not enter the cabling into a 70 degree enclosure because obviously then that temperature rating would be exceeded. If a conductor was to reach a high temperature, you'd have something like a cold tail maybe, where the manufacturer would put in wiring or sheathing that would accommodate that kind of connection, where you've got a hot cable to a power cable. But if you're talking about just running a cable for a higher ambient temperature and the cable's rating is larger than the enclosure, then that's not acceptable. You'll have to increase the enclosure's temperature rating. Okay. We also have impulse withstand voltage, which we talked about briefly in section 44. Chapter 44. Protection against overvoltage. The equipment shall be selected so that its impulse withstand voltage is at least equal to the required minimum impulse withstand voltage. According to the overvoltage category, the point of installation is defined in section 443. So that was where we had category 1, category 2, category 3, and category 4. Category 2 is the typical domestic type equipment at 2.5 kilovolts. We then have a brief mention on external influences. We'll cover a lot more on external influences when we come to the cable selection process, but it just gives you a little brief preview on it. Equipment shall be designed appropriate to the situation in which it is to be used, or its mode of installation shall take account of the conditions likely to be encountered. If it does not, by its construction, have these characteristics relevant to the external influences of its location, it may nevertheless still be used on the condition that it's provided with appropriate additional protection in the erection. So you could put a 13 amp socket outlet white, outside, but you'd then have to put it in an enclosure to achieve the requirements of IP ratings such as IP44, IP54, whatever the outside environment requires. Where different external influences occur simultaneously, they may have independent or mutual effects, and the degree of protection shall be provided accordingly. Yeah, so we always make sure we consider both, or multiple ones. And we're going to do that in the cable selection process as well. We're going to actually identify the external influences, the things that affect cable current carrying capacity, and if they coexist, if they happen simultaneously, we will combine those. We'll combine those factors. Selection of equipment according to the external influences is necessary not only for the proper functioning, but also for the reliability of the measures of protection for safety complying with these regulations. That was chapter 41. Measures of protection afforded by the construction of equipment are valid only for the given conditions of external influence, and the corresponding equipment specification tests are made in these conditions of external influence. We're going to cover this later on in 52, but in case you're interested in what those mean, they are used in Appendix 5. Those little external influences there. But we'll cover them in Chapter 52 anyway. Moving on to accessibility. Short and sweet. Except for a joint in cables where Section 526 allows it to be inaccessible, every item of equipment shall be so arranged to facilitate its operation, inspection, and maintenance, and access to each connection. Such facility shall not be significantly impaired by mounting equipment in an enclosure or a compartment. Everything must be accessible for maintenance unless it's been designed to be maintenance-free. This is a couple of pictures I took on a domestic. This was under the stairs, and they decided during some refurb DIY at home, you can just see the piping here, they decided to put a toilet under the stairs, and this is the back of the toilet, so the toilet's backing onto this wall, but actually you can see the service head is here, and then there's an RCD and there's a socket, and then the rest of the fuse board's around the corner. This bit of timber here is this bit here, so the fuse board is actually around the corner, and it's completely inaccessible because of this wall. It's this is now a toilet. So the solution they came up with is in the toilet, when you actually sat on the toilet, they cut a hatch in the wall. So to get that fuse board, to maintain that fuse board, you'd have to go and sit on the toilet. So, domestics. Now, 514, identification of notices. Very common, very popular in your exams, so there's your little preview on that one. Lots of little things that we can see here. So, general, except where there is no possibility of confusion, a label or other suitable means of identification shall be provided to indicate the purpose of each item of switchgear and control gear. Where the operator cannot observe the operation of the switchgear and control gear, and where this might lead to danger, a suitable indicator complying where applicable shall be fixed in a position visible to the operator. So far as is really practicable, wiring shall be so arranged or marked that it can be identified for inspection, testing, repair, or alterations of the installation. And except where there is no possibility of confusion, unambiguous marking shall be provided at the interface between conductors identified in accordance with these regulations and conductors identified to previous versions. Hence the two-colour label kind of thing. 514.3 Identification of conductors. Except where 514.6 comes into account, cores of cables will be identified by colour or letters and numbers. Every core of a cable shall be identified by its terminations and preferably throughout its length. With colour, neutral or midpoint. If a circuit includes a neutral or midpoint conductor identified by colour, the colour will be blue. The protective conductor. The bicolour combination of green and yellow will be used exclusively for the identification of a protective conductor. This combination shall not be used for any other purpose, and with this combination, one of the colours will cover at least 30% and at most 70% of the surface to be coloured. So when you come to the yellow and green, you need to have no more than 70% of that being one colour and no less than 30% being the other. Single core cables identified by green and yellow throughout their length shall only be used as a protective conductor and shall not be overmarked at their terminations. A bare conductor or busbar used as a protective conductor will be identified where necessary by equal green and yellow stripes, each not less than 50mm and not more than 100mm wide, close together either throughout the length of the conductor or in each compartment and unit and each accessible position. So that's the labelling of the protective conductors. The pen conductor, it will either be green and yellow throughout its length with blue at the end, or blue throughout its length with green and yellow at the end. Other colours, other conductors, green shall not be used for anything, such as live conductors in power, protective conductors or functional earths. They won't be used for any of those. Conductors by letters or numbers. The lettering or numbering system applies to the identification of individual conductors and of conductors in a group. So it must be clearly legible and durable. Yeah, durable meaning, it needs to last. It needs to last for the life of the installation. There'll be strong contrast to the colour of the cable. The identification shall be given in letters and or Arabic numerals. In order to avoid confusion, unattached numerals 6 and 9 will be underlined. So if you have an unattached 9 or a 6, there must be a line underneath it to show which one it is. Protective conductor. Green and yellow identification shall not be numbered other than purpose of circuit identification. With alphanumeric and numeric numbering, the number 0 is reserved for neutral or midpoint. And then you have some omissions. Table 51 gives you a good list of colour markers and alphanumeric markers. So you may obviously get a question that says along the line of, the colour the colour of a control circuit, extra low voltage and other applications for a line conductor is not. And the answers could be orange, yellow, pink and green. And obviously it's not green because green's not allowed. But orange, yellow and pink are in there. So you can see what they can do with that. These are just the different ways to actually identify protective any kind of conductor. Identification of a protective device. It should be arranged and identified so that the circuit protected may be easily recognized. 514.9, that's kind of like this one here. This is very, very popular. Legible diagram, chart or table or equivalent form of information shall be provided indicating, in particular, the type and composition of each circuit, including the points of utilization served. That's why the NIC ones and the others have number of points on them. Number and size of conductors, type of wiring, etc. The method used for compliance with regulation 410.3.2. Again, they would normally have like protective measure being ADS. That's for that as well. The information necessary for the identification of each device performing the functions of protection, isolation, switching, and its location. Any circuit or equipment vulnerable to a typical test. For simple installations, the foregoing information may be given in a schedule, such as the schedule of test results. A durable copy of the schedule, though, will need to be put adjacent to each distribution board. Right? Don't forget that. That could be quite popular, that one. So, yeah, a durable label fixed adjacent to the distribution board. We also need to be aware of our warnings for voltage. We must have a warning for voltage if a voltage is to be somewhere that it's not expected. So if I had a 230 volt socket outlet and I have 230 volts behind it, I won't need a 230 volt label on the front. If I had a 2 gain light switch and one gain was on L1 and one gain was on L2, I would need a 400 volt label there because when I lower that accessory, I need to be aware that there's 400 volts there, not 230. Isolation labeling, periodic labeling, hasn't changed much. The RCD label has changed slightly. The frequency has now been increased to 6 monthly with the test button. And it also says in here, under 514.12.2, near each RCD in the installation. So this RCD used to be installed at the board. It now says each RCD in installation. So again, if it's at the board, fine. But if you have these RCDs within the installation, then technically it's saying we should be putting these everywhere. The notice shall be inscribed in indelible characters not smaller than this illustrated in the book. So no smaller than what's in the book. We then have testing frequencies of the RCDs as temporary installations may need increasing because of the dependency on RCDs and temporary systems. DOT 13. Earthing and bonding connections. Now, hopefully you'll all understand the wording, and you should probably have seen these tags enough to know this wording by heart. But the labelling says, safety electrical connection, do not remove. Now this must be placed at the point of connection of every earthly conductor to an earth electrode, the point of connection of every bonding conductor to an extraneous conductive part, and the main earth terminal if the main earthing terminal is separate from the switchgear. So if your main earthing terminal is outside of the board, you don't connect one between the protective conductor and the exposed conductive part. Okay, so you can see how they can correct a question from that if you're not sure. You may have in your mind, oh, you put one on the gas, you put one on the water. Well, those are both option 2 there. They're both extraneous conductive parts. You need to always think a little bit deeper than that. And we have labels for bonding connections. We have non-standard colour again. And we have alternative supplies. The last little bit, 515, prevention of mutual detrimental influence. Equipment shall be selected and erected so as to avoid any harmful influence between the electrical installation and any non-electrical installations envisaged. Where equipment carrying current of different types or at different voltages is grouped in a common assembly, such as a switchboard, a cubicle, control desk, or whatever, all the equipment belonging to any one type of current or any one voltage may be effectively segregated wherever necessary to avoid mutual detrimental influence. So this is where, you can have within an installation, band 1 and band 2 circuitry, and then there's a risk of induction of the voltage from band 2 to band 1, which can have a problem. Or it could be where you have an issue with regards to a non-electrical system. Such obviously as this is obviously an excessive example, but a common example I have seen a few times is extraction fans, when you specify an extraction fan and you don't consider the amount of the air that it actually is being moved in liters per second, and then sometimes you can buy one that's excessive, and you may end up spilling gases by having, obviously, if you have a cooker or a boiler in the same room in a kitchen with a large fan, there could be gas spillage. So there are restrictions in the appliance standards and in the building regulations with regards to the liters per second for direct extract. But again, that's outside of the scope of the wiring regulations, but it can create a detrimental influence if we don't consider it and we don't actually design it properly. And a very good example is here. There. So this would have been a mutual detrimental influence. So we'll have in the dado trunk in the band 1 and the band 2. But then they put a heater underneath it, and so there was another influence there that was detrimental. We've got to try and avoid this stuff because, that's no good. That's no good. Alright guys, those are the common requirements. The next chapter, chapter 52, we're going to break down probably to 2, maybe 3 videos. We'll see how we go. Alright, but I'm going to break it down a little bit. It will include the cable calculations as well at some point. So it's quite a good chapter 52, and I'll see you on that one very soon.